and then we'll dive into using I1 Profiler and show you the software. So just wanted to let you know that it's not going to be an all PowerPoint snooze fest. We're going to actually work with the software and show you how it functions. So we're going to talk about what you're going to need to know when it comes to display calibration. We're going to speak about what proper viewing conditions would be, what the recommended settings for your display would be, and how you can validate how good the display quality is, both the display itself as well as the profile that you create. We're going to talk about the concept of soft proofing. And soft proofing, for those of you who haven't come in contact with it yet, is a way to anticipate what your file is going to look like before it's printed. To do that, you're going to be involved with creating a monitor profile because we need to make sure that the monitor is showing us what's in the digital file. We'll talk about the profiles that are necessary for soft proofing, and we'll also discuss whether soft proofing actually affects the file's contents or whether we're just using this for a preview condition. Now let's talk about viewing conditions first. There's two conditions that typically a graphic person would be involved with. One is looking at their monitor, and the second would be viewing a printed result for evaluation. Talking about the monitor situation first, typically you'd like your room to be dark if possible, but ideally you want to have the monitor being the brightest thing in your field of view. That's pretty easy to achieve even if you're in a normally lit room. Back in the olden days of offset work, typically people who worked on computers would be tucked away in a windowless room, gray walls, next to no lighting, and they would just be focused on what was happening on the monitor. So a setup that someone had less than 32 lux or 32 candela per square meter in their room was pretty normal. The color of the light was set to 5,000 degrees Kelvin. But in most cases, the monitor was by far the brightest thing in the field of view of the person operating the computer. Now, when it comes to viewing printed work, the more light, the better. You notice that the light booth here is saying that it has 2,000 lux, or almost 100 times more than what someone would have in their room lighting. There's almost not, you can't almost have too much light when it comes to viewing a print. 5,000 degree Kelvin would typically what we classify as being daylight. So if you take something outside and view it at noon, the sun's color temperature would be approximately 5,000 degrees Kelvin. That's what we've standardized on in the graphic arts industries as being a standard viewing illumination for printed work. So we've got monitor on the one side, we've got our printed work on the other side. Now in terms of what you need to do properly to make sure that your monitor profile is crafted correctly, step one sounds simple, but please make sure you clean it. Particularly in today's age of touch screens where people tend to get in the habit of touching their monitor's screen, whether it's glass or just has the flexible LCD panel. You want to make sure that it's clean. Ideally, you'd like to let the monitor warm up for at least 15 minutes and 30 if you can arrange it, because the monitor will take a little while to come up to operating temperature and to stabilize. And we talk about the concept of calibrating regularly. That, to a certain degree, depends upon your workflow and the type of monitor that you have. Back in the days when people were using cathode ray tubes or CRTs, daily calibration was advised and weekly calibration was probably the longest you'd want to go, because the monitors, the CRT monitors, would change a fair amount during the course of a week's time. With an LCD monitor, today's monitors are very stable, and if you built a monitor profile today, it should be valid probably for the next month or so. The one proviso is you want to make sure that you're not doing it on an absolutely cold monitor. You want the monitor to warm up first. But once a month would be sufficient for monitor profiling. In terms of the settings you want to choose to profile your monitor to, the color temperature and the gamma we'll talk about in a minute, but first we're going to discuss luminance, how bright your monitor is. Now most monitors have a brightness control that will go between 0 and 100%. But that doesn't necessarily correspond into knowing exactly how bright your monitor is. When we take and express the brightness of your monitor in a unit of measurement, then we're going to call it luminance. Typically, we're going to ask people to profile their monitors to a luminance level of 120, and the unit of measurement is CD/M squared, or candela per square meter. Some people also refer to this value as lux. Now, in the ISO standards for evaluation of pre-press work, they advocate a higher luminance level, but what we found for most people is that if they have their monitor set to too high a level, they tend to adjust their files, and when they send them to be printed, invariably they get a darker result than they were expecting. So if your monitor's too bright, your prints will be too dark. And we'd recommend 120 as being a good starting point for almost everybody who's printing to an inkjet printer or a color laser. To a certain degree, it's going to depend upon the printing papers that you're working on. If you're working on a gloss paper that's a very bright white, then the luminance level of 120 will give you a very close resemblance on screen to what the printed result would be. If you're working on a matte paper, you may find you can drop your luminance target down to 110 or even 100. Again, it depends upon the type of paper that you're trying to simulate or at least anticipate what your printed results are going to be. If you're in an environment where you have more than one monitor connected to your computer, you want to make sure that all of your monitors can achieve the same luminance target. So if, for example, you have an older computer where the monitor just won't get bright enough anymore, you wouldn't want to set your newer, brighter monitor to a higher luminance level. Then you'd find yourself adjusting a file differently depending on which monitor you viewed it on. So if you have more than one monitor, you have to make sure that all of your monitors can achieve the luminance target that you aim for. Today's monitors, that's not much of an issue. Most monitors are capable of being very, very bright. 400 to 500 candela per square meter is not uncommon these days, whereas even monitors of, let's say, 4 or 5 years ago might be hard-pressed to get above 120, even at 100% brightness. The gamma or contrast ratio, we recommend 2.2 for either PC or Mac users. People who have been around in the industry for a while, particularly those Mac users out there, might remember that once upon a time we specified a gamma of 1.8 for Mac monitors. That had more to do with trying to make a Mac monitor match an old Apple LaserWriter printer than actually choosing the correct gamma setting. Apple was faced with a choice way back when. They could either redesign the engine that went into the Canon laser engine that went into the LaserWriter printer, or they could choose the 1.8 gamma setting to make their monitor look similar. That's no longer an issue. Almost no one's printing to a black and white laser printer for critical work anymore. So 2.2 gamma would be the correct setting in our estimation for all PC or Mac users. Our software does allow you to vary the gamma setting if you do want to play with that. But again, if you're dealing with more than one monitor, make sure everyone's choosing the same gamma setting, and our recommendation would be 2.2. Now we talked about soft proofing. And soft proofing is a very, very useful feature that's built into Adobe Photoshop, and I believe now is also included in the latest versions of Lightroom. And what it allows you to do, it allows you to anticipate what a printed result is going to look like before you print something. Now, if you have a printer in your office, you may say that that's not necessarily a big deal, but if it can save you from printing something in error, then you're going to save the time and the materials involved in doing that print. When it comes to sending files out, particularly if you're sending out a lot of different files to be printed at a remote location, soft proofing is a vital step, and you want to make sure that you do this before you send any files out to be printed. And then it requires two things. It requires that you create a monitor profile, which we'll show you how to do today, and it requires that you have a printer profile provided either from a printer manufacturer or a lab if you're sending your files out to a lab, or one that you might create with software such as our i1 Profiler software if you build printer profiles. So under the View menu in Photoshop, the top choice is Proof Setup Custom. And then when that window comes up, you have Customize Proof Condition where you choose the device you're trying to simulate. In this case, we're trying to simulate an inkjet printer that's printing with magenta as well as light cyan, light magenta. So it's using eco-solvent inks and printing at 720 by 720 on a semi-gloss material. That's what the verbiage here, abbreviation, means. And then when you preview by checking the preview checkbox off and on, your screen preview will change slightly. Or if your profile is particularly not well crafted, it might change dramatically. But what you're trying to do here is you're trying to see what's going to happen to your file before you print it. Now that requires that a monitor profile be built correctly and that the printer profile be appropriate for the type of material and the printer that you're going to use to print your work. Also in Photoshop, you have the ability to choose gamut warning. And the areas that are highlighted in this neon green, these are the areas that are at risk of clipping. And clipping just means that this color is not capable of being perfectly reproduced or accurately reproduced, I should say, with the profile that you've got on the paper that you're using with the printer that's involved. Now in some cases, it may never be fully or correctly reproduced with anyone's printer. Bear in mind that our monitor is capable of showing us colors that just can't be reproduced easily on anybody's printer on anyone's substrate. So in this case, it shows you the areas that are likely to have a slight problem. And then usually what you can do by doing just a very little bit of judicious editing in Photoshop, you can minimize those out-of-gamut areas so they're no longer affecting any substantially important areas of the image. We recommend that people do their editing before they convert to a rendering intent for final printing. But the thing to keep in mind here is that if you see an area that's out of gamut, it doesn't mean that it won't print. It just means that it won't print and be as accurate to the screen as you might have expected. In most cases, you're going to see a very, very slight difference from the printed result, but at least the gamut warning shows you the areas to watch out for. So now what we're going to do is we're going to have a look at how to actually do this. We've talked a bit about the theory behind it. We're going to go and fire up i1 Profiler software. Let's minimize PowerPoint. Let's go to i1 Profiler. i1 Profiler, for those of you who haven't seen it, is our flagship profiling software package, and it's designed to be the replacement package for what we previously marketed as i1 Match, which came with everyone's i1 Pro or i1 display device, Profile Maker 5 from Greytag Macbeth, or Monaco Profiler Platinum, which came from X-Rite. Back in 2006, when Greytag Macbeth and X-Rite merged, we had the three programs that were serving this profiling market. We've tried to bring them all together in i1 Profiler. And i1 Profiler has two faces. It's got the basic mode and it's got the advanced mode. For people who are using an i1 display before or an i1 display 2, they will likely find that the basic mode is all they really need. If someone was working with Profile Maker 5 or Monaco Profiler before, they're likely to venture off into the advanced. I'm using the i1 Display Pro as my colorimeter or my measurement device, and this would be a device that would allow me to measure anything that emits light. A monitor or a projector can be profiled with an i1 Display Pro. If I wanted to do printer profiling, you'll notice that it says demo here, meaning that I don't have a device connected to it right now that would allow me to build a printer profile. That would require a spectrophotometer such as our i1 Pro or our i1 Pro 2 device. Let's take a quick look at display profiling. Clicking, we're in the basic mode to begin with. Clicking on the display profiling button first, it sees that the screen that I'm trying to profile is a color LCD. In this case, I'm working on a MacBook Pro. And then it correctly identifies that the display type of light that's used in the backlight is a white LED. And if you want information about what these various types of devices are, over on the left-hand side, you'll see a verbiage about the various types of backlight materials or backlight technologies that are possible. So you'll see that i1 Profiler software has the ability to profile CCFL equipped monitors, and those would be LCD monitors of, let's say, 5 years ago up to about 2 years ago. Then if you had a particularly expensive monitor from those days, that might have been a wide gamut CCFL. And this is a fluorescent lamp, by the way. The majority of monitors on the market today are white LEDs. Almost every Apple monitor is white LED. And then you can also find some specialty monitors out there that use an RGB LED array. Some of the very newest ones, OLED, are just starting to hit the market. They're ferociously expensive, so I don't expect too many people will be dealing with an OLED screen just yet. We've also added in the ability to profile plasma screens. And we also have red-green phosphor screens. Again, those are fairly rare to find in the marketplace. Or projectors. And digital projectors are a market that's increasing its use quite a bit. Many photographers will use a projector to project their work to clients. Let's go back to what we're set for here, CCFL. Our color temperature and our default color temperature that we recommend highly is D65 or 6500 degrees Kelvin. If you set your monitor to D65 and you get an image that looks correct on your screen, when you print it out and view that printed result under 5,000 degree lighting, the results will be very similar. We won't bother to go into all the theory on why that is. Suffice it to say that if you set your monitor to D65 and then view your print under D50 or 5,000 degrees Kelvin, you're going to see a very close resemblance. Luminance we talked about a moment ago. You can choose a luminance target. We said 120 is our recommended, but you can choose a different target if you wish, or you can enter a custom value. Native means that it's not going to change the brightness of your monitor at all. Bear in mind that most people, by default, tend to have their monitors set up to a much brighter level than 120 candela per square meter. We also have a feature called Ambient Light Smart Control, where we can vary the profile based on the room light and the amount and the color of the room light that's in your area. I'd have to argue that that's probably a control that I don't want you to begin with. That's not something that's going to affect your profile greatly in most cases, and we're of the school of thought here, at least in the support department, that you only want something changing your monitor that you're in control of. So after we've made those settings, then we're going to click Next, and then it'll tell me that my device is ready, and I'll see all the measurement patches that it's going to go through and measure. With the small number of patches that I'm measuring right now, this is approximately a 2-minute measurement task for it to do this. Now, the i1 Display Pro has a couple of different ways to be controlled. One is called Automatic Display Control, where the profiling software has the settings that we've chosen, and then we just ask it to go through and automatically adjust the brightness of the monitor. We also have the ability to override that and choose to adjust our brightness, contrast, or RGB gains manually. Now, in the case of my MacBook Pro, I don't have any contrast control, and I don't have any RGB controls either. So the only control I'd be adjusting manually in this mode would be that of brightness. And then we would hit the Start Measurement button, and it will go through and measure the various patches and build the profile. I'll save that for a minute. We'll go back and have a look at the advanced mode, and then we'll go through and do the actual measurements so you can see the measurement of the patches go through. So we're going to switch to advanced. Display profiling. Again, all the same settings that we had before. We're going to leave our contrast ratio at native. If I had more than one monitor I was trying to make look similar, I would want to choose a standard contrast ratio. And typically that's going to be the contrast ratio of your least capable monitor. Flare correct would be used if I had a glossy screen monitor and I had a lot of room light that was causing reflection. And Ambient Light Smart Control we talked about a moment ago. Notice that we've got a couple of different things in the advanced mode. We've got the asset pane on the left-hand side, where we can save previous settings or previous profiles and re-invoke those. We also have the workflow down at the bottom. Clicking on the profile settings takes me to the next step in the process. And here we can choose whether we want to create a version 4 or a version 2 profile. A version 2 would be used by people who are using a program that couldn't understand a version 4 profile correctly. An example of that would be Windows Photo Viewer on the Microsoft PC side. That particular piece of software prefers to have a version 2 profile. On the Mac side, I think Final Cut Pro would be an example of a program that doesn't know how to correctly understand the version 4 profile, but it does know how to use a version 2 profile. And again, Gamma, we recommend you leave it at 2.2, but you do have variability if you wished. And profile type, you can either choose matrix-based, which will build a small, efficient profile, or table-based, which will take more measurements, more computations rather, and build a larger digital file in the profile. The end result will be probably indistinguishable for most of us unless we've got an exceptionally good monitor. I'm going to leave it in matrix-based just to keep the profile size small. In patch set, we have built-in small, medium, and large. And not surprising, you're looking for about 2 minutes, 4 minutes, or 8 minutes if you want to do the large number of patches. You also have the ability to extract color values from either a range of spot colors that you brought in from a program such as our Pantone Color Manager, or colors that came in from a particular image that you wanted to sample. I'm not going to be involved with doing that for you today, but that would be the type of thing if you always knew that you were doing a certain type of image on your screen and you wanted to make sure that your profile was correctly rendering all those subtleties and the color values found in those images. That would be where you'd extract some color patches from that image. So we've chosen the small. Now we're going to go to the measurement stage. Again, we have the choice of automatic display control, where we'll handle the brightness adjustment for it automatically, or we can do things manually. I'm going to leave it in automatic display control mode and click Start Measurement. The first thing it's going to tell me is that the ambient diffuser on my i1 Display Pro is covering the lens, and I'm going to rotate it to the back. Then we get a message that comes up that says, make sure the device is resting flat on the screen. If you need to, tilting your monitor back a bit to let the weight of the cable, and the cable weight rather, and gravity hold it in place. But you want to make sure that the flat part of the lens is flush against the glass or the LCD screen that you have. And then click Next. What it's going to do first is it's going to make sure that my luminance is set to the correct level. So it's going through and looking what the range of my monitor's luminance values are. and correctly determining how to adjust the backlight, in this case the white LED backlight, so they have the correct luminance value. And I've asked for a luminance result of 120 candela here. After it's done the measurement for that, then it's going to move into starting to measure color patches. Some monitors will not respond properly to automatic display control. They might already have a feature on their monitor called DDC, or digital data channel. In that case, turning ADC off in our software would be the right thing to do. You may run into this with some higher-end monitors that already have certain circuitry in them that's trying to control the brightness of the monitor automatically. So ADC would be the first thing to try, but if you run into a situation where your monitor profile ends up being exceptionally dark, much more so than it should be, the first thing to try would be turning off the ADC in our software or turning off the DDC in the menu of the monitor. So it's going to go through and measure the color patches right now. The software knows what these color values should be, and then after it does the measurements, it sees what those color values are on your screen, and then based on the difference between the two, it will build an ICC profile. On a PC, it's called an ICM profile, but they're interchangeable. You can use an ICC profile on a PC, you can use an ICM profile on a Mac. You can copy them on a thumb drive and move them between computers if you have a screen that you're sharing amongst computers as well. So it's going through right now and doing its color measurements and building the table information that it needs to create the profile. These profiles are stored inside a folder on your computer. On a Mac, they're inside Library Color Sync Profiles, or if you're logged into your Mac as a user and not as an administrator, they're in User's username, whatever you call yourself, Library Color Sync Profiles. On a PC, not quite as straightforward a path. The profiles are saved on your C drive, which is your boot drive. Then they're inside Windows, System32, Spool, as in spool of thread, drivers, and finally color. So that's the location where those profiles live. On a Mac, your profiles will be used by almost every program available that runs on a Mac. On a PC, profiles are not used universally. Anything from Adobe will use your profile. Anything from X-Ray will use your profile. And next to nothing from Microsoft, with the exception of Windows Picture Viewer, will use your profile. If you're using other people's software, you want to check to make sure that that piece of software is able to understand an ICM or an ICC profile. It's finished doing the measurements that it needed. It asked me to turn the ME diffuser back over, covering the lens again, and then set it off in front of my monitor. What we can see here is we can see that it's done the measurement of the patches and that all the color values look approximately correct. There are going to be some slight differences between the expected and the actual. That's because no monitor is perfect. After it's done those measurements, then we move to the next screen. I'll give it a name, and we'll call this Color LCD, and we'll call it HQ. And we're going to save that to my user level folder. We're going to create and save the profile. After it's built the profile, now I can see the profile either in gamut view, where I can see a spatial representation of the shape of the gamut. And what we're looking for here is that it doesn't look like an asteroid. The sides should be smooth. It's a geometric shape. We can see the chromaticity horseshoe, and it tells us what our targets were, and it tells us what we actually achieved. We were aiming for D65 or 6500. We achieved 6493K. We were aiming for 120 as a luminance ratio, and we got 119. That's visually indistinguishable. And the contrast ratio was native, and my particular MacBook Pro has a contrast ratio of 770. What we can see here is that there's some divergence between the red, green, and blue channels. That's because my monitor isn't by default 6500 degrees. It needed some correction of these various channel strengths to give me a proper result. And then finally, you can look at a before and after, and because video presentations over the web won't use the profile I've created, you won't see any difference on my screen on before and after, but my screen does become considerably more neutral in the grays when I switch between before, when I wasn't using a profile, and after, when I've got the new profile invoked. So that's the creation of the profile. After you've built a profile, then you can go through and evaluate it and get a quality evaluation. We'll talk about that in a separate webinar sometime. You can also do a test to see the uniformity of your monitor. where it will check to see if your monitor is similar in terms of luminance and color temperature across 9 different quadrants on the screen. It's not going to correct area by area, but it will tell you if you have a monitor that has a significant deviance across the screen in terms of how bright the screen is or what the color temperature would be. That would be the display QA, but we'll have to deal with that in a separate session. So going back to home, that's I1 Profiler software. Display profiling and projector profiling are available with an I1 Display Pro instrument. If you wanted to build a printer profile, then you require to have a spectrophotometer like our I1 Pro or an I1 Pro 2. Even though it says demo, you can still go through all the various stages of going to build a profile, so you can see what the I1 Profiler would do if you were to build printer profiles. The one thing you won't be able to do is to save the resulting profile unless you have an I1 Pro connected. So let's go back to our PowerPoint. Here's the tools of the trade from X-Rite. I1 Publish Pro 2 is our combination of I1 Profiler software, which you just had a look at, in conjunction with a spectrophotometer, the I1 Pro 2. The I1 Display Pro is the instrument that we just used with I1 Profiler software. Again, the software is identical. The difference is that this is for people who only need to profile monitors or projectors. And then we also have Pantone Color Manager that's installed along with the I1 Profiler software package. And Pantone Color Manager allows someone to see what's going to happen to their colors from a Pantone range of colors that they might select based on a particular print profile that they might want to use. It also allows you to make sure that your Pantone colors, you have correct palettes of colors that you can exchange with programs such as InDesign or Illustrator or Quark.
Well, that's a great presentation, Bruce. Thank you
Thank
very much. Yeah, and we'd like to, again, extend our thanks to colorHQ for inviting us to this webinar. We appreciate that. And Bob, if you want, you can kind of speak to this audience as to how they'll be able to get these solutions through you.
Sure. Well, absolutely. And thank you again, everyone. Bruce, thank you. And thanks to all of our attendees. Certainly, we are here to help our customers. So if anyone has any questions following this, obviously you can type them out right now. You can always call us. I think most of our customers know that. We're always available to talk. We do have some specials through the weekend here on the Deal of the Day section, which is on the menu on the top left side of our website. Deal of the Day on the I1 Photo, the I1 Publish, the I1 Display Pro, and also the Passport Color Checker. So we do have those on special for anyone who's been viewing this webinar.
Okay, great. Well, as Bob mentioned, if you have any questions, feel free to type them in, and we can begin our Q&A session right now. The first question that we have, Bruce, is can I profile my Epson R2880 with my I1 Profiler Pro?
You can profile your Epson printer with the I1 Pro or the I1 Pro 2 spectrophotometer, depending upon whether you are printing through the Epson printer driver, in which case you're profiling it as an RGB printer, or if you're profiling it printing through a RIP, then you typically will be profiling it as a CMYK printer. The key here is that you need to have an I1 Pro or an I1 Pro 2 spectrophotometer to build a printer profile. The device we use today, the I1 Display Pro, wouldn't allow you to profile a printer. Same piece of software, different piece of hardware.
Okay, very good, very good. Well, Bruce, I don't see any other questions. If there are any questions, you can quickly type them in. But once again, Bruce, I want to extend our thanks to you for a very nice presentation. And once again, thanks to colorHQ for bringing us all together to present this information. So are there any other further comments, Bob, that you want to have in conclusion?
No, I just look forward to talking to everyone soon, and thanks again for joining our presentation. Great.
And that will wrap up our webinar for today. So thank you very much for your attention.